Okay, so now in our last video, let's try to solve this game. So we will start from analyzing the first situation, that whether it is possible for both firms to offer the warranty plan. So we start by setting that the two decisions WH and W1 are WL are both 1 and 1, so that we know both firms wants to move to the left. In that case, the next step is for the consumer to determine what's the posterior belief, because we know the posterior belief is completely determined by the manufacturer's decision, by the principal's decision. Okay, so we need to set P and Q according to the base rule, and then we can decide what's the consumer's best response, and then at the end we verify whether 1-1 is really no one wants to deviate from that. Okay, how do we decide P and Q? P can be determined as a conditional probability, right? P is nothing but the probability that the product is reliable, given that we observe 1. In this case, this is extremely simple, because all we need to do first is to find the two terms in the denominator. It will be that the probability for the product to be good, which is 1/2, times the probability that when the product is good, the probability for the manufacturer to choose to offer a warranty plan. In this case, because this is a pure strategy, going to the left, this probability is just 1. When the product is good, the manufacturer is going to offer the warranty plan definitely. Similarly, if the product is bad, the low type is also going to offer the warranty. So it's 1/2 plus 1/2 times divided by is 1/2 or 1/2 times 1 divided by 1. So it will be 1/2. What does that mean? That means here, when you observe a warranty plan, you get no information, you get no signal, because they are doing the same thing. So that's why your posterior belief is the same as your prior belief. Okay, so now we have P is 1/2. For Q, we actually have no clue, because no one is going to play to the right? So in that case, Q can be anything, because base rule help us nothing. And then let's talk about the consumer's action. The consumer is now facing this question: if I see warranty, what should I do? If I see no warranty, what should I do? If I see warranty, definitely I'm going to buy this product. So I have B here. If I see no warranty, then I may get 5 or -7. I'm not sure. And whether I should buy it really depends on Q. If Q is high, then 5 can dominate -7 and I will buy it. If Q is small, I won't buy it. But Q can be anything, right? So the decision here can be anything. It can be either B or N. However, if we think about firms, then what's going to happen if A0 is B? Is that possible? If that's the case, if A0 is B, then no firm is going to offer a warranty. Why? If A0 is B, that means both of them, the consumer will buy the product anyway. If the consumer is definitely going to buy the product, then the firm will be better off by offering no warranty, right? Because you just don't need to pay the repairman cost. So that means A0 cannot be B, and the only possible equilibrium will be B and N. The consumer will buy it if there is a warranty, but do not buy it if there is no warranty. However, we still have one thing to do. We need to make sure that the firm is really going to stick to this assumption, stick to this plan, but that's wrong. The unreliable firm is not going to do that. Suppose the unreliable firm anticipating this. The unreliable firm sees that the consumer is going to do not buy it with no warranty and buy it with warranty. Then what should the unreliable firm do? The unreliable firm is thinking that if I offer the warranty, the consumer is going to buy it. I'm going to earn -1. But if I do not offer the warranty, the consumer will not buy it. I get 0. 0 is greater than -1. So as the low reliability manufacturer, I'm going to deviate. Okay. So after all this analysis, we get one conclusion. 1 is impossible. Okay? No, because it does not satisfy all the equilibrium requirements. Okay, so yeah, that's the first case. We have 3 cases to go, but now we are more familiar with that, so it will maybe easier. Is it possible for both of them to offer nothing? To offer nothing, going to the right? In that case, again, the next step is to form beliefs. As we mentioned, the 2 guys are doing the same thing. So if you really apply base rule to calculate it, or just by intuition, you get no information at all. So your posterior belief is the same as the prior belief. For P, it can be anything. Okay? Yeah. So indeed, that's something we should get. And then according to that, what should the company do? Sorry, what should the consumer do? Is the following. Suppose I see the warranty. Suppose I see warranty. Again, in no matter what's happening, I should still buy this product. Even if P is 0, that means it's just bad. I should still buy it because it's good enough and the warranty plan can really protect me. Okay? So A1 will definitely be B. If I see a warranty, no matter what's the reliability, I will buy it. But for no warranty case, I definitely will not buy it, right? Because now I know Q is 1/2. 1 minus Q is 1/2. So as a consumer, I am averaging 5 and a -7. As I get -1, I should not buy it. Okay, so if the firms do so, I will form this belief. According to this belief, I will make this response. And now the next thing is to determine whether the firms will really do so. Suppose I am a reliable firm. What's going to happen? Here I am assuming that I do not offer the warranty and the consumer will not buy it. I earn only 0. If I offer the warranty, then the consumer is going to buy it. I'm going to earn 8. 8 is definitely greater than 0. So if I am reliable, I should deviate to WH equals 1. That means it's also impossible for both of them to offer no warranty. Okay, so now is our third case. Is it possible to have 1, 0? Is it possible that the high type offers a warranty but low type does not? Again, we need to calculate the posterior belief. Here, if we want to calculate P, it will be the following. With probability 1/2 is the high type, and then with probability 1, there is a warranty. With probability 1/2, there is a low type, and the low type will not offer the warranty. Completing the calculation, we get 1. You know, if the manufacturers really do so, if the manufacturer really separate their decisions, okay, then if you see a warranty, you know it's a high type selling a product. Okay, so that's how you get this P equals 1 and the Q equals 0 posterior belief according to their decision, like this. So now, how should the consumer make decisions? If I know it's the high type, then I should definitely buy it, right? 6 is greater than 0. And also, if I know it's the low type, then I should definitely not buy it because -7 is just bad. So that's how I get this. Bn is the optimal response for the consumer. The last thing is to check whether 10 is really good. Does anyone has the incentive to deviate? The current situation is like this, right? So as a manufacturer, currently as a high type, I earn 8. If I choose not to offer, consumer will not buy, and I get 0, not good. Or as a low type, currently I get 0. If I choose not to offer the product, consumer will interpret me as a high type guy, and the consumer will buy it. I earn 0. I earn -1, which is even worse. So that means this is good, no one wants to deviate. This is indeed an equilibrium. Okay, the last case. Is it possible that the high type offers no warranty and the low type offers warranty? Oh, it's just, no one wants to deviate. Okay, yeah, this is the last one. Is it possible for the high type to offer no warranty but the low type to offer warranty? In that case, Q is 1, P is 0, and then what will be A1 and A2? We can show that it will be buy and buy. Why? Suppose you see a warranty. You know it's a low type offering a warranty, but you still get 3. That's good enough. That's good. That's better than getting nothing. Or if you see there's no warranty, it's fine because you are facing a high type. You still get 5. So you will buy in either way because 3 and 5 are greater than 0 and 0. But in that case, the unreliable firm is going to deviate. Why? Because currently, as an unreliable firm, I offer it, and then the consumer buy it. It becomes -1 for me. But if I do not offer it, then the consumer is going to leave the product away because the consumer will feel that the warranties and there's no warranty is not good enough. And as a manufacturer, I just earn 0, which is better. Okay? So in that case, the unreliable firm is going to deviate. So collecting everything for our game here, the unique equilibrium is this one. The reliable manufacturer is going to offer a warranty and the product can be sold. But the unreliable manufacturer will not offer a warranty and the product cannot be sold. The key reason, part of the reason, the key reason here, why this is going to happen, is that the unreliable manufacturer has an option. The unreliable manufacturer can choose to offer warranty so that he can pretend to be reliable, right? But as we mentioned, if you go back to check the game tree, in that case, the unreliable company, the unreliable manufacturer is going to earn -1, which is worse than providing just no warranty and get the product unsold. Okay? So it is because that this K is so high, this RL is so low, so that this becomes the equilibrium. The reliable firm can successfully signal her reliability in this case, and the system can become more efficient because the consumers can tell the type. And as we mentioned, it is because it is too costly for the unreliable firm to mimic the high type. In general, there are pooling, separating, or semi-separating equilibria in a signaling game. We say if this is a pooling equilibrium, all types will make the same decision, and then the agent cannot tell anything. Or if this is a separating equilibrium, everyone will make different decisions, and so that when you observe the outcome, when you observe the principal's action, you can tell who he is. Or finally, if this is a semi-separating situation, then some of them will do the same thing, but not all of them will do the same thing. So you can partly reveal the principal's type. In this example, the unique equilibrium is a separation, which is very good because we always prefer the unique equilibrium outcome, right? But for most signaling games, there are multiple equilibria, and separation may be just one of them. Multiple equilibria will mean everything is possible. Yeah. And in that case, you cannot make a perfect prediction on how people will react to everyone. Okay? But at least the separation is one possibility in that case. But for some other signaling games, it is possible that no separation is possible. Okay? It may be the case that there is no separating equilibrium, and thus, in equilibrium, it's impossible for a good guy to signal its quality or reliability or productivity. Okay, that's possible. We're going to see these examples in class, and yeah, that's going to provide you a more complete picture for signaling games. Thank you.